And we're just going to sort of revisit some of the milestones that we like to kind of highlight from the last year. We're going to talk about where we are in terms of, the DuckDB project, adoption of DuckDB around the world. And we'd also like to give you a bit of an outlook on what we think will be things that are going to shape the next year of DuckDB. Okay. So before I want to give you a bit of a disclaimer here, because we have had a slide where we kind of said what we're going to do in the year that has now passed in the presentation that I've just mentioned in February 2021. And we promised a bunch of things there. And you can, if you look at the list, some of these things have happened, others have not. So just as a sort of heads up, this is more like what we imagine and not necessarily what we're gonna sort of promise or even like don't sue us over this. Okay, that would be great. Okay, so I think and we're going to look at the DuckDB version 0.25 to 0.34, which just came out this week, actually.
Yesterday, even.
Yesterday.
Was it yesterday? No. Yeah, was it? It was, right?
I don't know. We should know this.
We should know this.
but yeah, we're going to look at these version range, and Mark will go into the individual versions. So I'm just the click bot now. So you have to give me a hint. Okay.
Hint. Thank you very much, Hannes. Yeah, so we had the idea of doing like a kind of a quick recap of the state of the duck, the year of the duck, essentially what has happened since more or less 1 year ago, since the last time we did a kind of a big-ish presentation about specifically like the entire system. We've had, of course, presentations about different components and stuff like that as well. But I think the last like real duck presentation was that DSD talk in February 2021, so almost 1 year ago. And as we're planning to iterate on this DuckCon, of course, and have this be like more of a yearly thing, we'll have like, kind of one of these slides every year. At least that's kind of the idea. So kind of there's quite a lot of things that have happened in the last year with DuckDB. It's been progressing very fast, also because we've gotten a lot of people working on it, a lot more than when it started, when it was just Hannes and me hacking around in our small little offices in Amsterdam. It's now like a proper sort of project with a reasonably sized team. So the progress has certainly been accelerating, and it's super exciting. So I'm just I'd love to take you through all the highlights of all the things that have happened in the past year. Maybe some you've heard about, some we've written about in blog posts as well, and maybe some like small things that you have missed, or maybe some small things that may be cool that you didn't know about, just as a sort of like, hey, this might be useful if you're using DuckDB. And I guess a lot of people here are using DuckDB, otherwise you may not be here. Or all right, so yeah, let's start with the first release after this, after February in last year, and that was the 0.2.5 Falcata. And there's this beautiful picture of a Falcata duck. So for those that don't know, our version numbers, they're based on a like species of duck. Is it species? I think it's species, type of duck. And of course, all of these come with lovely pictures.
Sorry,
it is species, right?
I just didn't find the unmute button.
So sorry, thank you. Yeah. The species of duck. So this is a Falcata duck, as you see. And I think you will be surprised by how many species of duck there are. I think we're still good for the foreseeable future until we have to come up with a new versioning scheme. All right, so 0.2.5. Well, I think around this time, I don't know if it was actually coupled with the release. It was more like a separate project. We had, of course, the WebAssembly release, and that was super exciting. where well, this work was mostly done by Andre. We took DuckDB, or well, he mostly took DuckDB and made it work in the browser in WebAssembly, which is super cool because this enables well, so many crazy things. And it was quite nice talking to Andre about this this project. He said one of the reasons this was possible was because of the design of DuckDB, where we essentially have no external dependencies. Because otherwise, if you have to have like 20 external dependencies that may themselves have 20 external dependencies, this stuff gets like progressively more and more difficult to port to the browser, especially if it's like a C++-ish dependency, because that is like, it's not fun, let's say, as your dependencies increase. So for DuckDB, that was not a problem, and it was actually quite straightforward. I mean, still a lot of work, but comparatively straightforward. And there's this demo website, if you have not seen it, the shell, the web shell, where you can try out DuckDB like running inside your browser. And it's super cool because you can load data from a remote storage into your browser, or you can run analysis on your local computer, and it's all in JavaScript, all in WebAssembly, and it's pretty fast. So very neat, very cool stuff. Other stuff in this release that we had was incremental checkpointing. That's kind of before this happened, there was like a long-standing problem where we just rewrote the entire database system every time there was any change to it when you shut down the system. So incremental checkpointing, it sounds kind of easy. It's not that easy. It was not that easy, but we did get it working, thankfully. And it makes, well, the system a lot more pleasant to run as an actual database system, right? Because you don't have to constantly, like, as your amount of data increases, it becomes more and more unbearable to rewrite everything. In this release, we also had the progress bar. This was done by Pedro, and this is very cool because now when you run a query, if you enable the progress bar first, so there's an example on the slide there. If you enable the progress bar, it will show you the progress, and it will do this by looking in the actual scan. So if you're reading a CSV file, it will like look how many bytes of the CSV file have I consumed. And it will most of the time give you pretty accurate progress of the query. And it can do this for anything. I took a copy as an example, but it also works for a select statement or what have you. Any sort of complex query this should work on. So that's super neat. And this release, we also had tons of aggregate functions, as Pedro had taken it upon himself to finish our backlog of aggregate functions. Well, there's a big list of them there. They're all in the documentation as well by now, of course. So it's also, yeah, super cool. All right, next. Excellent, cool. Then on the 8th of May, we had Jamai Kensis. I don't know how to pronounce the name. I probably should have looked that up before this presentation. Doesn't matter. Beautiful duck, a blue beak, which is quite unique, and also a beautiful release. We had massive improvements to our sorting operator, courtesy of Lawrence, and also good improvements to our window functions, courtesy of Richard. Essentially, before these improvements to our sorting algorithm, we had a super slow sort that I wrote in like 2 hours, because at the time I just didn't really care about sorting performance, because it doesn't matter for TPCH, right? You only sort 10 rows. And then, well, at some point it starts mattering. People come with bigger and bigger queries. Window functions are kind of like, yeah, that's a thing as well, of course. So it ends up becoming quite important in the end anyway. And so Lawrence has done some tremendous work on that. We also had improvements to the arrow scans. We already had them, I think, before, before February, but we started adding support for parallel arrow scans in this release, which is of course super cool, because it means you can process arrow buffers in parallel. And our arrow support in DuckDB is top notch, by the way. Like if you have any data stored anywhere, you can use arrow to read it and then read it into DuckDB, and it's going to be very fast and parallel. It's excellent. Some more niceties that we had was the replacement scans and the array syntax. So the replacement scans, that's kind of the idea that if you have a query that fetches data from a table. If the table is not there, it will actually potentially replace it with an equivalent table function. So for example, if you see the query there, select star from album.parquet. If there is no table called parquet in the schema album, then what we can actually do is we can check, hey, maybe there's a file that is a parquet file that we can read instead. And that's kind of what these replacement scans do. At the time, it was only used for CSV files and parquet files, but it's turned out to be like quite powerful and also very elegant, because you can we're using it, for example, in our Python libraries, so we can read like data frames from within this the scope without having to do any sort of extra registration step, which makes this super convenient. Area syntax, of course, also. And then there's the table-to-table UDFs, which is quite a powerful concept, where you can essentially operate on a table. You get a table's input, and you can provide a table's output, which is quite powerful. It's used in the Python client, I believe, right now. You can create them yourself. And this allows you to essentially create new operators in the system. So that's super like a flexible user-defined function, of course, super. All right, next. All right, the Mollissima in June. That is also a beautiful duck. Is that actually in the ocean or not? That looks a bit like, I'm not sure. Are there saltwater ducks? We should have done more.
Exist.
They
yes,
do exist.
They exist, yeah. I'm not sure about this one.
Okay, I also see I have messed up the formatting on the table, don't mind that. So this released some more ergonomic stuff on the Python style, like a list and struct syntax, so you can create lists and structs in the way that you're familiar with, which I think is makes this super nice and ergonomic. That's otherwise usually quite complex. Like if you want to make a struct of a list in Postgres or some similar system, it's quite challenging, the syntax for that. In DuckDB, it's super easy. You just do what Python does. They have thought about this. They use it a lot more than database people usually, so looks nice. Also, one thing is the compatibility views for the Postgres catalog, which that's kind of like every database system has their own unique views or system catalog stuff that's kind of unique to them. And one of the things that we found quite powerful is creating like imitation layers for what the other systems are doing. So we have this now for SQLite and for Postgres. You can see an example for that query there, where we have this this table called PG class and PG namespace. These are Postgres views, and this also works in DuckDB. And that's kind of like an extra compatibility sort of layer inside DuckDB that makes it possible to use drivers written for Postgres like as is on DuckDB, which is of course quite powerful because we also have the same parser. We support a lot of the same syntax. Also supporting the schema tables allows us to use like components written for Postgres, or if you have like queries lying around for Postgres, it works. And in particular, this one allowed us to use the Postgres SQL Alchemy driver like as is. So we just run the same one as the Postgres one, which is probably pretty well tested and such as well. So that's kind of a cool thing. This was also when the ODBC driver first made its appearance. That has been like an ongoing project by Tiago for the past year or so. It's of course also super useful, super cool to have for a database because, well, you want people to connect to you. What better tool than ODBC? And then there's the row group based storage. That's more like a backend thing, essentially like a reorganization of how we stored tables on disk, more aligned with what Parquet does. And this was kind of like a precursor to enabling compression and such later on in a better way. So there's like the back end for enabling compression, which we now also have. All right, next one. Yes, the Ceruti. Very nice duck as well. As I said, you'll be amazed how many species of ducks there are. In this release, we added the struct and the list storage, so like the storage of complex types. And kind of a cool thing about this is that all my tables got oh, I think I know why. It's because I used a font that is not on your computer. Yeah, okay, got it. Sorry about that.
Hang on, I can fix this. I will fix it. We'll do
okay,
it live.
okay. We do it live. Thank you, thank you. Yeah, it's the shared keynote is a problem. Yes, perfect. Wow, it looks so much better. Excellent. Yeah, so one of the cool things about how we store structs and lists is that we store this recursively as like recursive columns. So if you have a column, like let's say an array of integers, like in this example here, where we store these totally randomly chosen numbers, plus bonus points if you know the reference. Instead of storing like a bunch of blobs in a or like strings or something similar to strings in a column, we store this as two separate columns, one with the list offsets and the other one with the actual list data. And this is really flexible because, well, one, DuckDB is a columnar engine, which means it's optimized for columns, so storing data in columnar format is better. Like that's what the system is optimized for. Like going from row to column has a cost, which actually I'll talk about a bit later. But also because this allows us to use like our existing compression infrastructure also to store lists. So for example, in this example, we store two columns. Both are just like a bunch of integers. Even though the actual data type is complex, what we're storing is just integers, and integers we know how to compress, or are quite like straightforward to compress, much more so than like blobs of integer arrays. Another cool thing about this is that it also allows you to do like arbitrarily complex types, right? Like you can store structs of structs of lists of structs, and it all just works because it has this like recursive definition, and it's all like quite efficient. So if you are using structs and lists in DuckDB, don't worry about them being slow. Let's say that we actually did benchmark them; they're quite fast compared to most other systems, even ones that are optimized for like OLAP as well, because they don't do this approach for structs and lists. Another cool thing that happened in this release was the unified row layout. So this was a cool work by Lawrence, where we essentially, for the sorting and also for other operators, there is like kind of an intrinsic need of going from columnar to row. This happens for hash tables as well. So for an aggregate hash table, for a join hash table, because you kind of have these, well, SQL has row-wise semantics, right? So there's quite some points in a database engine, a columnar database engine, where you have this transformation. Now you don't strictly need to do it. Like it's an optimization thing, right? You could keep data as columnar, but one of the nice things about storing data in row is that all the data is like adjacent in memory, which makes it a lot faster. And you can imagine if you do like a join, I'm looking up a single row, right? A single tuple. If I have my data in like 10 different columns, looking up a single tuple means accessing 10 random spots in memory. Looking up a single row means accessing one random spot in memory. And that's one of kind of the big performance things in a modern in-memory database is, reducing random memory access, because that turns out to be expensive. All right, cool. Constant value compression, kind of a side note. Let's go to the next one because I think I'm taking too long. Thank you.
I'll fix this again.
This one was a monster table. Yeah, that looks much better. All right. So this one we had kind of the very big thing, which was the compression or storage, which was kind of like what the other things had been working towards. It was kind of like one of the super nice features of the columnar system is that it lends itself very well to compression. When DuckDB was first designed, we didn't have it. Now we do. And what we made is kind of like a sort of a generic layer that allows us to implement more and more compression algorithms. So actually in this release, we only implemented RLE, but the existence of the layer and like this compression structure allows us to add new methods. We have now added the dictionary compression method as well, and we're still planning to add more in the future. There's also the summarize function. I'm just going to skip like a few of those. Oh, actually, this is cool. This cool table in the bottom left shows where we are at now in terms of compression ratio compared to where we were at last year on the New York City taxi data set. So you can see that currently we store like 1 year of this taxi data in 6 gigabytes compared to Parquet's 4 gigabytes. Last year was 14 gigabytes, so without compression. CSV is 17 and SQLite is 20. So we're already progressing quite sharply, and with, of course, the goal of matching Parquet without having to use heavyweight compression algorithms like Snappy, because that makes your subsequent query processing a lot slower. That's the kind of the downside of using a thing like Snappy. All right. So summarize is a kind of a cool thing. Oh, sorry, I gave it soon. Summarize is a cool thing where you can put summarize before any query in DuckDB, and it will tell you like the names, the types, and all like statistics about your data. It will like run a sort of analyze command. It's very useful if you're new to a data set and you just kind of want to inspect it. All right, next 0.3.0, the Gracilis, the evil duck because of the red eye. This one was kind of more like a bug fix release. We had the exclude and the replace clauses, which makes the select star a bit more convenient to use. We have the UUID data type. And from Diego, we have the perfect hash join, which kind of speeds up joins on small integer domains, which is quite cool. It's used automatically by the system. It's like a cool performance trick. Then 0.3.1. This was quite the Spectabulas, very, very pretty duck, of course. This was a very big re-engineering of our execution engine, where we switched from a pull-based execution model to a push-based execution model, and this allows us to parallelize things that we couldn't parallelize before, and is also kind of a stepping stone to adding support for example, async I/O in the future. So that's super cool. Was quite a big engineering effort, as you might expect, to kind of switch out the execution layer out from under it, but it has worked very well. And there's a talk I gave about this on DSD. I think there's a video as well if you go to the website. So that's linked there. Besides that, we had grouping sets and enums. Enums are super cool. They're added by Pedro. It's very cool. There's a SQL there, but often you won't need to write the SQL, because what we do with the enums is that we generate them automatically from either our factors, Palmas categorical types, or from actually our strings at all, which allows the system to process these things much faster. So it's like there is a SQL syntax for it, which is the same as Postgres, of course, but the underlying technology enables a lot of cool optimizations, and you don't even need to know it exists, essentially. Like it's very, very cool. It's been very useful so far, right? All right, the 0.3.2, the Gibber de France. In this release, we added the time zone support. Well, Richard has done a lot of work on that, which is super cool because, well, time zones kind of important for data. Also very important in our daily lives nowadays, now that we have Zoom. So it's super nice to have good support for that. We had loadable extensions. That's kind of a big one, which we're super happy with. I'd say sort of because it didn't actually work quite well on all the clients on Linux, which is one of our biggest systems, but we should have gotten working now. And that's kind of cool because this allows anyone to write extensions to DuckDB that they can install and load from their system. And a lot of our own functionality is actually written in these extensions. So it's not like some sort of add-on thingy. Like all of our Parquet support is written as an extension. The HTTPFS is written as an extension. And we're constantly working on turning actually existing stuff into extensions as well as writing new extensions ourselves. So we are super committed to making this like not just some hook to change minor things about a system, but actually make this super powerful so you can have very big control about it. Then we have to explain analyze. That's again like a cool little trick. that you can prefix to any query. So you can just go to the beginning of the query, add, explain, analyze, and what it will do is it will time the query and show you like the profiling information. All right. Oh, next one.
Sorry, Mark, there was a question about unloading extensions. I think
Would you unload extensions to minimize that script?
I think you cannot DL unopen something, right?
No, well, the thing is that right now we bundle extensions with certain clients. So the Python client, or actually most of our clients, they come bundled with the Parquet extension, at least. I think almost all of them, or maybe even all of them come bundled with the Parquet extension. You can turn the bundled extensions off at compilation time. The extensions that are like that you load, you can just not load them, of course. You can restart and not load it. But once they are loaded, no, you can't really get rid of it. Questions about the progress bar in release 0 to 5. Are they based on cardinality estimation? But they're not based on cardinality estimation. Actually, they hook into the scans of the query. So they look at like the, let's say you have a join, you have 2 scans. It will kind of just look at the cardinalities of the base tables or CSV files or Parquet files, and it will do like a calculation based on the current progression into the scan. And it works perfectly if there's one table. If you have like 2 tables and you have a cross product, it can mess things up, of course, but in general, it works quite well. All right, cool. Let's go to the next one before we run through our time. Yeah, and then we have the last release, which I don't actually have that much time to talk about, which was this week, where, well, we added a bunch of cool stuff. Lawrence worked very hard in adding JSON support, also as an extension. So there is now JSON support in DuckDB, which is based on the JSON support of the SQLite client. I think we basically have almost or all of the functions SQLite has for JSON, and we support all of that as well as the like JSON type. And there's a lot more work to be done on this in the future, of course, mostly around optimizing the performance, but the support is there, which is super cool. Hannes did a lot of work on making the SQLite and Postgres readers, which is super cool as well, which now allows DuckDB to read data directly from a SQLite or a Postgres database. Again, both of these are extensions, and these are actually our first out of 3 extensions where they're in a different repository, which is kind of like for us as well, like a kind of
learning curve.
A learning curve, yeah. Let's see how it goes. But the functionality is there. It's cool. It works. We have an official Julia client now, so I've been working on that. And well, it's not uploaded yet, but we're almost there. It's almost on the official Julia thing, and that also works very well. We've added foreign key support. Actually, not we. We have we've added. A very nice person has added foreign key support. Let me actually look up his GitHub username because I have. I should have put this in the slides as well. Shenshi8611. Yeah, he has added foreign key support, which we now have, which is also super cool. Sam has worked very hard in adding S3 writing and globbing and dictionary compression. Also very cool features. And Tanya has added 1-based indexing. So this was kind of a mistake we made early on to go for 0-based indexing, even though we all prefer it, of course. It's not like compliance to the SQL standard is more important. So that is, we have switched that now, which is good. All right, then I will hand it back over to Hannes. Sorry for taking too much time. It was too many releases.
There's a question about why would you transfer data from Julia to DuckDB? I think the answer is that Julia is not, of course, a SQL engine. Julia cannot run SQL queries, right? So if you wanted to do that, you would have to move stuff over. So I think that's probably a good reason why you would want to go back and forth. But by the way, this release is named after an extinct duck. So even if we run out of living ducks, we're not in trouble yet. Yeah. So let's look a bit at where DuckDB is right now. So in terms of adoption, I pulled again the similar slide we did in February 2021, and it's pretty crazy. We went from 10,000 installations a month in Python to something like 150,000 installations a month. This is, of course, according to the PyPy stats. Something similar happened with R, where we went from 2,000 installations a month to 12,000 installations a month from a single mirror, like the only one that publishes these statistics, and they have hundreds of them. Also growth in Node, not so crazy. Java, also some improvement, but not so crazy. There was quite a lot more of direct downloads. There's a lot more GitHub stars. And what is really interesting to see, and I don't think that was there yet in February 2021, was where we could see, let's say, serious other projects integrating with DuckDB. For example, Jonathan is going to talk about the Arrow integration in a bit. Philip has worked really hard on the EBIS wrapper for DuckDB. We have integrations in things like we have never heard about, like, oh, this other project that is super huge on GitHub has suddenly added some sort of support for DuckDB, which was really cool to see that. What also happened is that DuckDB Labs has happened. So DuckDB Labs is a spin-off from the CWI, where DuckDB was originally designed. And we made so Mark and I co-founded a spin-off company called DuckDB Labs, which employs most of the core DuckDB team. It is not VC funded, but instead derives its sort of the money it needs to run from strategic partnerships with other companies, usually companies that do something with data as well. DuckDB Labs also makes extensions. So, for example, the SQLite and Postgres extensions that Mark has just mentioned is something that comes out of DuckDB Labs. It's not something directly out of the open source project. DuckDB Labs has at the moment 12 staff. Here's a picture of them. I think most of them are in the meeting. So hello everyone. And we are currently actually planning our office in Amsterdam. And of course we're hiring. So if you would like to join DuckDB Labs, please do get in touch. The question was, is there a planned integration with ClickHouse? Not sure. I would say it's not on top of our list. I think we would probably do Snowflake before that. Okay, then what also happened is that the DuckDB Foundation happened. So it's a bit uncommon, let's say, for open source projects, I think, but we have actually disconnected DuckDB, the project, from DuckDB Labs, the company, in that DuckDB, the project, is housed in this non-profit foundation called the DuckDB Foundation that is only concerned with long-term survival of the project. It's kind of further, it's there to further the open source roadmap of DuckDB, and we encourage commercial users of DuckDB, of course, to donate and join the DuckDB Foundation as supporting members, because it's kind of keeps the lights on in the project, and we're very, very happy that we have already managed to gain some of these supporters. So we have Voltron Data and Relational AI on the gold level, and then there's Hex, Watershed, Notable, and Mode on the silver level. And if your company uses DuckDB commercially and is not on this list yet, then it should be. Let me, before I hand over to Jonathan for the Arrow talk, I will maybe talk a bit about where we think we are going. And as I said, don't sue us if we don't manage this, but this is where what we want to do. So there's a couple of points. The first one is out of core, and this is something that Laurens has been spending a lot of time on, and probably will spend more time on. And what is this? So it's actually interesting. Out of core means that the intermediate data that query operators collect, for example, a sort, a join, aggregate, and so on, is able to be bigger than memory. And this is quite uncommon for query engines. And I think there's very many that will simply not be able to deal with this situation. But we think in DuckDB, we want to never give up and never surrender in terms of query completion. And even if an intermediate should be bigger than memory, we still want to have a viable and not horribly slow strategy to complete queries. And this is something we're going to spend more time on. Mark has mentioned this already, that sorting was the first operator that we made this work for. But there's more to do. There's aggregates, there's joins, there's window functions, and there's a mystery operator that we forgot. Mark, did we remember now which the mystery operator is?
I forgot that we added this to the slides. I still haven't figured out which it is.
I still haven't figured out. There's maybe another operator that we can't think of right now. If you know which operator it is, do apply for a position in DuckDB Labs. We clearly need you. And the IE join. Now that's just okay, Richard, you already work with us. We also want to spend time on the storage format. So DuckDB, of course, can read a lot of interesting formats like CSV, Parquet, data frames from R and Python, data frames from Julia, and Arrow. But we also have an internal storage format, which basically is persistent database files on disk. And Mark talked about how we added compression to that. And at the moment, you have probably run into this yourself. When you make a new release, there's a nice note that says, hey, please note that the database format has changed and you need to export your data from the old version, import it again, a new version in order to actually continue working. This is because we are still making breaking changes to the storage format. And it's actually something that we'd like to end, sooner than later. Obviously, we have to be a bit careful because we want to provide backwards compatibility for this storage format once we stabilize it. So that means that if we make horrible mistakes, we will be bound to them forever, which is creating a little bit of paranoia, let's say, on declaring it finished just yet. But this is something we want to do. We also would like to, Mark has mentioned how the compression API that DuckDB has for the row groups is actually generic and is pluggable. So we also plan to add more compression formats to the DuckDB storage format. For example, something that we'd like to do is to add the FSST string compression method to DuckDB. There's also some planned work on join orders, which we haven't spent a huge amount of time on yet, and it's important for some use cases, and so we'd like to do some work there. And we also like to think a bit more about indexes and specifically persistence of indexes. So this is kind of it's a lot, but I think from the list that that Mark has just gone through from the last year, it's not too crazy to think that we can pull these things off, but we'll see where we end up. So that's the end of my slides. There's a question about geospatial type. There's actually an intern, I think, that's probably going to work on this soon. So there might be something there. It doesn't mean we're not going to work on anything else. It's just the things that we think are important for the project to go forward. Okay. There, of course, if you have any other questions, then you can always shoot them in the chat, and I will be happy to respond. But are there any immediate questions that you'd like to ask? And if so, please do raise your hand and we will unmute you. No, not yet. Oh, this. Alex has a good point. The DuckDB, if you are a member of the DuckDB Foundation, you can also your voice is heard when we think about which roadmap items to tackle. So I think that's also an important benefit. And on our website, we have a list of all these things. Anyways, if there are no immediate questions now, then I will. And as I said, if you can always shoot them in the chat later if you like. Then I would hand over to Jonathan. And hang on, Jonathan, yes. You good?
Yep.
Okay, then I would say then let me quickly introduce Jonathan. Jonathan is a software engineer at Voltron Data, and we've been working together on integrating DuckDB with Arrow, specifically on the R front. I think it's kind of your home base, and we're very thankful that Jonathan is giving a presentation today about Voltron Data's efforts on bridging Arrow and DuckDB. So all yours, Jonathan.
Absolutely. Thanks for inviting me. I do not think I can see the chat, so feel free to chime in if there are questions in the chat. I'm happy to
I will
be interrupted. Yes, awesome. Thank you again for inviting me. I'm going to talk a little bit about Apache Arrow, and I do kind of think it's a little cheeky to show up at a open source projects meetup and be like, I'm going to talk about this other open source project. But if you stick with me, you'll see how they are integrated. And that kind of is the foundation of a lot of the relationship that the Apache Arrow community and the DuckDB community have as we're working together. And it's something that we're both passionate about, building these types of bridges. So I'm excited about that. So a little bit about me. I'm an engineering and data science manager at Voltron Data. I manage, like Hannah said, the R team, as well as some of the performance engineering that we're doing at Voltron Data. I was trained as a linguist back in the day, but I've been working in engineering and data science ever since. A kind of fun side project that I maintain is DStB, which is a package for mocking database interactions. So I have databases and packages for databases kind of coursing through my blood. Before Voltron Data, I was working at Ursa Labs, which is one of the kind of founding members that came together to form Voltron Data. And before that, I was at Secure and Crunch. So a little bit about Apache Arrow, if anybody is unfamiliar. It is a multi-language toolbox for accelerated data interchange and in-memory processing. And we'll talk a bit more about the in-memory processing, but a bit of history. We were founded in 2016 by a group of open source developers. And kind of the core idea was to unify database and data science tech stacks with this single in-memory representation for data. We have a thriving community, which I'll get to in a slide. We have 12 different languages that implement the Arrow in-memory storage format. And then we have a couple of other projects alongside that with various levels of support in different bindings, but it's quite broadly implemented. And we've been adopted by a number of projects and other products in the ecosystem. I should probably put here a link to our Powered By page. Whenever I look at that, I'm like, oh, wow, there's a lot here. Awesome. So we have, just like DuckDB, sustained growth across users, contributors, and applications. Our latest release is 7.0, which is our 24th major release. We are in the process of getting ready to release 8.0, which should be coming up shortly. We have over 35 million monthly PyPy downloads. I've seen higher numbers. I might have pulled these numbers wrong, so it might even be more than that. And then 60,000 from the same single mirror from R, and over 800 contributors. So everything is up and to the right, like it should be, which is exciting. So I'm going to talk a little bit about some new features in Apache Arrow, and we'll connect those into DuckDB as we go. So one of the side projects on top of this memory representation that Arrow has is a query engine that's written in C++. There are a couple of other query engines that use Arrow data, like Data Fusion and Rust, but one of the ones that has been seen a lot of work recently is the C++ query engine. And there's a lot of ongoing work. So far, we've tackled numerous common scalar functions, grouped aggregate functions, joins. We're working now, and this next release should see a number of new scalar functions, as well as performance and efficiency improvements. And beyond that, we're looking at window functions and additional join types. We're also working heavily on the Substrate project, and this is a collaboration across a number of different groups, including the folks at DuckDB. And what Substrate is it's designed to be a cross-language interoperable specification for these types of data compute operations. So we want a standard flexible way that we can take the APIs for data manipulation and plug them into the engines for actually running these queries, be that engine DuckDB or the Arrow query engine. And we're also working on producing kind of end user APIs around these. So kind of making a dplyr wrapper around Substrate that can then connect in, or an IBIS wrapper, stuff like that. And then all of these will be consumed by engines. again, like our C++ engine, DuckDB, and possibly others. We are actively working on this, as are the folks at DuckDB, so stay tuned for more, but this is a very exciting new frontier for everyone. And also I should mention, if you are curious about this project, substrate.io is the URL. So talking about Apache Arrow as a bridge, I have two case studies here. One is something that we already covered a little bit earlier, which is that DuckDB and Arrow can use the C data and C stream interface in Arrow to pass data back and forth. And the really awesome thing about this is that it's a zero copy integration. So when you're not serializing your data into some intermediate format and then unserializing it into DuckDB's format when you pass it from Arrow to DuckDB, you really are just passing a pointer and saying, here's the data, find it there. And I'll show this in my demo in a little bit. The DuckDB integration also is nice because it can push down filters and projections into Arrow, which will become important in the demo as well. And there are bindings for this at a user level for both the Python and R APIs in both DuckDB and Arrow. Another case study of a similar philosophy is an improvement Streamlit you just made or recently made. So they've started using Arrow to move data between Python and JavaScript. And this massively reduces their kind of server browser transfer times because of the common interface, and you're not dealing with serializing, deserializing. And you can see here, this is just this massive diff between the legacy way of transferring a 5,000 by 5,000 data frame down to minuscule compared with Arrow. Additionally, for them, it allowed them to delete something like 1,000 lines of code, which is fantastic. You get like massive speed improvements, and you get to delete code. I don't know who wouldn't be down for that. This is a fun blog that they wrote about this process. So now for the live demo, what everyone is excited about. So this, and you can see our studio on my screen, right? Awesome.
That's yes.
Yes. And so just to show, this is not actually a cooking demonstration. This is a totally fresh session of R. So I've not loaded anything in here yet. The environment is empty. And so all of this is real time, like actually processing all of this data. A couple of libraries that we're going to need. What I'm doing is, so I'm based in Chicago. So of course I had to say, yeah, the NYC taxi data set is cool, but I'm going to use the Chicago taxi data set. So I've got the Chicago taxi data set here. I have saved it locally, and I partitioned it by year. We've got 2013 through 2022, year, month, day down here, and their individual Parquet files. In total, this is 19 gigabytes. The laptop I'm running this on right now has 16 gigabytes of RAM. So like I could not read all of this into RAM right now in R, even if I wanted to. That would be a terrible, terrible idea. But we are still going to be able to analyze it. I also grabbed some community area information from the Chicago Data Portal and loaded it up with a couple of simple features columns so we can visualize these. All this is a data frame of the like community areas, their names, and their geographic boundaries. Cool, so let's get to the meat of this. Using the Arrow package, you can open a data set referencing the directory where those Parquet files are. And the cool thing about this is it's not actually doing much other than just checking the file system and saying, okay, here are the files. It looks like you've got high partitions, so I'm going to add those as columns. You can see here, it'll take a little bit because let's go through each Parquet file and figure out how many rows there are. But there are a little bit under 200 million rows here and 26 columns. And we can see we've got a kind of schema here. We've got things like, your trip ID, trip start time, miles, census tracts, community areas, and stuff like that. So I've not actually read any data into R yet, or into Arrow yet. It's just kind of has the metadata for what this data set is, But we can still take that and query on top of that. This is similar to some of the demonstration queries that we used for Arrow for a long time using dplyr syntax. We start with our data set and we're going to filter by a year. I'm going to mutate and say, I want to look at only, I want to kind of separate the trips into trips that were in a single community area and trips that were across different community areas. And then I'm going to group by that and summarize and calculate some metrics about that and pull it in. So I can run this query, and again, we're on 200 million rows of data, and it's done. So when I timed this earlier, it was 1.2 seconds, which is pretty cool. And you can see here, we've got our intercommunity areas, trip metrics about that. The cool thing that Arrow is doing here, and the reason why it can be so fast, is that we're taking advantage of this partitioning. So we've got our year 2019 here. So we only have to read in the Parquet files that are in that one folder. We don't have to read in everything. But let's see if we can do something more complicated. So again, same data set, but instead of filtering by year, I'm just going to leave that year off. I'm going to do the same query. I've added in year to my group by. So I'm looking for for all of the trips that are within an area or across areas, and then by year, just to see what they are. Again, a bunch of different metrics. And all of this should be very familiar if you're familiar with dplyr, semi-familiar if you're familiar with IBIS. But one of the cool things that we've released recently is the ability to do joins in Arrow as well. So I've got my community areas Arrow table here, and so I can do a left join on that, so I can actually get the community area names instead of just the numbers. So I'm going to kick this off. Probably should have kicked this off before I started describing what the query was, because this takes about 30 seconds. So yeah, and this right now is actually processing the entire data set, but because we are not reading all the Parquet files in at once, we can do it in a streaming fashion. We're not going to run out of RAM. And we're also only taking out the specific columns from the Parquet data that we need to, which is super helpful.
We should have some waiting music for this kind of thing.
Yeah. Like I said, I should have kicked this off and then explained the query. So if anybody has any questions now would be a good time for like 15 more seconds.
This is always nerve-wracking when you do like a live demo that's taking a little longer. I know this is the longest 15 seconds of your life.
Yeah.
It's really,
but it's done.
Hey.
And so again, we've got our kind of different community areas here. This is actually by this wasn't inside or outside, it was just which community area you were being picked up in by year. And then we did our join to get the nice community area names. You can see here, we've got nice names of our community areas. We don't have just the IDs that come in the taxi data set. So this is a DuckDB meetup, so I couldn't do it without talking about DuckDB. I'm going to kick this one off first and then talk about it. So what I'm doing here is the exact same query we saw above, but at the beginning, I'm using this function to_DuckDB. And what that does is it wraps the data set in the query up, gets that pointer and passes that over to DuckDB and says, here's the data, like look for it at this pointer. DuckDB registers that as a kind of quasi view in DuckDB. And then after that, we can use standard dplyr syntax, which then gets executed via dbplyr. So it turns all this into SQL and executes it on DuckDB. So all of this, all of the kind of summarization and grouping here is being executed in DuckDB. The cool thing, actually, no, I'll talk about the cool thing in the next query. And so again, we got that same data here. And this is again on the order of 30 seconds to process all that data. And we've gone from Arrow into DuckDB and then back into R. I'm going to skip over the round tripping. I'm not going to actually run this, but I want to show that you can actually, so you've got your to_DuckDB operator here, which takes the data set or the query and kind of shoves the pointer towards DuckDB and says, look over here. We also have this to_Arrow operator, which does the opposite. So it takes a kind of dbplyr function that has a DuckDB result coming out at the end, and it'll pull it into Arrow, but again, via a pointer, so we're not copying anything. And with our newest release of Arrow, when that comes out, by default, this will be a streaming pull in. Right now, it materializes everything, but with the new release, it will stream in, which is fantastic. And then the really cool thing is, if what you want to do is actually run the SQL here and not use dplyr, you can do that too. So I'm going to create a DuckDB connection. And I'm going to do the same thing, except instead of carrying on after I did to DuckDB, I'm passing in my connection to tell it which connection to use, as well as a table name, so I know what to refer to it. And this will take a second, but it's not actually done anything. And this is kind of the cool thing about the pointer, is that I've only really set that pointer up to this data set and says, this is where you'll look for data, but we've not done anything with the data. And it's just a pointer to a data set that can be scanned to get data later. And so what I then can do is write this SQL query here, which is similar as before, where we have our pickup community area, year, various metrics. I also have I'm going to kick this off while I'm talking. I also have in here another where clause, just to show that this actually gets pushed down into that data set scan. So we're not pulling in all of the data here. Filter right here is actually happening during the Parquet scan in Arrow. The integration is smart enough to push that down, which helps tremendously speed up things depending on how selective this is.
There was a question, Jonathan, from Alexandre. When would you want to use 2 Arrow and 2 DuckDB?
So I found it useful if there are kind of things that are either more easily expressible in dplyr versus SQL, or features that are available in one or the other.
Thank you. There was another question that was a question from Amadou that says, is summarize across ... comma mean supported? Obviously, you can parse R code in your head and know what that means.
Yes, I do not think summarize across is supported yet, but I would have to look. Don't quote me on that, but I don't believe it is supported yet. And we have our result here. And I'm going to join this onto that community areas. And this is all in R because like I said, these have some geographic features associated with them. And we can actually show, I'm going to close the connection so I don't get any complaints about garbage collecting later, but show that we actually have results that are useful, or at least useful for demonstration. It takes a little while because plotting lots of points on a polygon, turns out, takes a little while, but I'll show up over here. And this is all R/GB plot. So here we go. We've got our maps of Chicago, and this is looking at, shows up. These are the trip seconds in mean, with trips starting from each of these community areas. And this kind of blob over in the upper left-hand corner is where the major airport is, O'Hare. And so lots of kind of long trips start there, which makes sense. And same thing on the kind of outer areas. There are longer trips from the edges than there are in the center. We can do things like look at what the tips look like from particular areas, because we calculated the mean of tips across all of these for different years. So one downside with maps and plotting in R is that the maps are slow, but they're pretty to look at. And so again, we see apparently if you're looking for large tips and you're a taxi driver, you should hang out near the airport, because that is where all of the large tips come from, which also makes sense if they're longer trips. Awesome. Well, that is the end of my demo and the end of my presentation. Thank you for being here. just like DuckDB Labs, Voltron Data is also hiring. So if you're curious about joining us, see our careers page.
Thanks so much, Jonathan. Really great to to see this, all this hard work that you've put in to make this a seamless integration. I think it's really great, and I think it's funny that R is kind of like on the forefront of this, for once.
Yeah, absolutely, and that's kind of true in Arrow as well. The dplyr interface is much more kind of built out on the R side. And the IBIS interface is getting there, but we definitely for a while had people on our issue tracker being like, why can't I do this in Python? I'm like, I don't know. These are.
The Python people are different, who knows?
Yeah.
There was another question from Reicho, I think is how you pronounce it. Is it possible to do a cross with dbplyr? I don't know, do you know?
Sorry, let me stop sharing my screen and see if I can read the.
Yeah, oh yeah, can you see it now?
Yeah. I don't know. I've never tried using cross and dbplyr together.
I think it's not actually a question, it's a statement.
Oh, it's a statement.
It is possible to use a cross with dbplyr.
Thank you. Okay, very cool. Are there other questions for Jonathan? Please do raise your hand if you want to ask a question, or ask it in the chat and we will unmute you. More waiting music required. Yeah, I think it's, as I said, I think it's pretty great to see that. Oh, there's a question. Let me yeah. Hi, Jamil.
I'm an R user and a Windows user, and I've been using Arrow with DuckDB and passing back and forth in order to handle big bits of memory and big bits of data. And I have run into various problems with out of memory errors. And it was good to learn that there's this issue with intermediate data in DuckDB. And I know that Arrow and DuckDB both have different things with threading and windows and whatnot. I wonder a lot how the streaming and threading and all that works, especially when you're putting these two systems together that are independently working on things like threading and out of memory.
Yeah, first comment from me. Yeah, indeed, the out of the memory management for intermediate is something that we are still working on. So it's great to hear that. Sorry, great to hear that you're using it, and sorry to hear that sometimes it doesn't work, but it's somewhat expected. Jonathan, did you want to comment as well?
Yeah, same. We have in Arrow, there are a number of places where we will kind of apply, as these kind of data scans are happening, we'll apply back pressure and say, like, stop reading, we got to do something with the other data first. But we are expanding greatly the areas where that happens and make that more robust. And we have definitely seen a number of pretty hard to track down threading bugs on Windows. So we very much appreciate minimal reproducers on the Jira when we can find them. We've definitely solved a few, but we know that there are still a couple out there that are plaguing people.
In general, with the streaming and the threading, that was your other question. I think that should work. I'm not aware of any pressing issues there. Did you run into anything?
I haven't been running into particular things, but it just is sort of mysterious to me as far as how all these things can be working together. I'm aware that R is single-threaded, and therefore, I don't know how much when all these things are interacting, whether they're fully taking advantage of the features in DuckDB and Arrow.
They are. They are. Yep. We run our own threads. We don't have to wait for R on this.
Yeah, and same thing in Arrow.
Alex, was that a question? Hang on. Okay, Alex has a question on the Arrow side. Can you read it, right?
Yes, yeah. Next data forms, and that's the you're most excited to integrate with. It's not real, it's like kind of sort of a data format, but just like the geo question earlier on the roadmap for DuckDB, a colleague of mine at Voltron Data is working on some really cool geo support in Arrow and trying to make that a first-class citizen, and especially being able to transport geo data between R and Python, either via like the C data bridge, like we showed here with DuckDB, where you can say like, here's the geodata, but also trying to add some support for actual kind of geo operations on geodata that's stored in Arrow format, and hopefully do that in a way that's interoperable and can cross the R Python boundaries.
Yeah.
Yep, exactly. Thank you, Rock, for that link.
Yeah,
and all of that stuff is kind of gelling as a standard as we speak, and we're trying to make sure, just like we do with Arrow, that we are kind of developing a standard that everyone can use and kind of meets at least most of the needs of people using this.
Yeah, we're also kind of curious about what comes out of this GeoParquet initiative or the GeoArrow initiative, because it's also something that we might adopt eventually. Okay, so I think normally if this were in person, I would say let's thank our speaker again. Thank you again, Jonathan, for thank you again for presenting. It's great that you could make it. And then in our wonderful program, we have the lightning talks scheduled now, and I propose that we start with Chris. And to do that, I think, Mark, you need to make Chris a co-host. Chris Kamphaus, you should be somewhere in the list there. You there, Chris?
Yeah, I think I found him.
Yeah, I think you did. Hi, Chris. Can you share your screen, and if you have slides, and just go and try to be like around 5 minutes, if that's possible.
Yeah. Can you hear me?
Yes, we can hear you.
Okay, let me see. So how does this look?
Looks
so,
good.
Yeah, after all this art talk, let's go back a bit and also talk a bit about Python, of course, to compensate. So I'm going to talk about DStB, and this is joint work with Arjen, who's my supervisor. And DStB was something we published at Desires in 2021, which is a information retrieval conference, which was inspired by Cider. So it's a system-like conference. And yeah, information retrieval is the science of search engines. So given a free text query, give back relevant web documents or books or news articles or whatever. And of course, DStB is a bit inspired by DuckDB, but another popular information retrieval package is called Answerini, which is the scientific name for geese. So Hannes previously published a paper in Sakayar 2014, which is called All Dog, or how I call it. And here he showed, together with some other people, amongst others, Jimmy, who makes the Answerini system, and Arjen, my supervisor, how to do information retrieval using relational databases. DuckDB also supports this. Lawrence implemented this, I think, and he wrote a great blog post about it. So I can definitely recommend everybody to read this as well. And however, data is often more complex than just text. So we want to implement or allow graph data to be queried in the context of information retrieval. So this can be knowledge bases, metadata learning to rank, which is machine learning for information retrieval, and do this using DuckDB. So for example, a task we are interested in is background linking, which means given a news article, find other news articles that are relevant background reading. And for this, we can use, for example, entity information or authorship information, because, for example, when a author writes a newspaper, other articles that were written by the same author are probably more relevant than by a random author, because people tend to write on the same topic. So our goal was to show the usefulness of the graph databases for information retrieval, and how we want to do this was model the data following a property graph model, and then basically use Cypher as a query language on top of DuckDB. And we use structure-aware storage. So when we have properties in the graph data that are very common, we store these as columns in the tables. However, because it's built on top of DuckDB, we can also use SQL as a query language and support the basic information retrieval functionalities as how they were described by the paper of Hannes. So we can just do easy exploration by doing probabilistic ranking functions and find relevant documents, and then do some post-processing given some graph queries, for example. The left schema we see here is the schema introduced by Hannes on how to model free text documents in a relational database. And we can see this same schema as a graph schema, which we demonstrate on the right side. And this graph schema we can then easily extend by introducing new types of nodes that we can query over. So in the context of background linking, this is the data we work with. So we have about 700,000 news articles from the Washington Post published in 8 years, and we have 50 examples of documents and which other documents are relevant in that context. And a graph that represents this data is shown on the right side. So documents can be linked to authors, but also to terms that appear in the documents. So we will show an example on how such information can be used. So on the right side, we have documents, is a Cypher query on the top, and this, given a news article, it shows all other news articles written by the same document, and the same SQL query that describes the same information need is shown at the bottom. So here, this is, I think, an example where graph databases make sense. So what we did, we tried to translate the Cypher queries to SQL queries and show that that this can be actually quite easily expressed, and this is built on top of DuckDB. So in this query specifically, we return all documents written by co-authors of the original author. So to conclude, DStB is built on top of DuckDB, and we try to combine information retrieval with graph queries. And if you want to use like a general purpose graph database built on DuckDB, I can recommend GrainDB, which was published at Cyber 2022. That's it. Thank you for your attention. And if you have any questions, maybe we have time, or you can send me an email.
Thanks a lot, Chris. Indeed, I'm amazed that the paper has a nickname, first of all, and that you use it for your work. Are there any immediate questions for Chris? And obviously, you could also ask him on the chat if there's anything you want to ask him directly. So far, I don't see anything. I think we'll go to the next lightning talk. And sorry for mispronouncing your name earlier. Rayo is next. Rayo, can you share your screen?
Yes, let's try. So, hello everybody. I'm Rayo Sund. I'm professor of register studies at the University of Eastern Finland. And I have been trying to find some solution to use some kind of good system in these kind of remote access systems where you need to process private data or restricted data so that there is a privacy restrictions. So, for example, the health data. So if you have heard about the European health data space or something like that, those are that is the future for that kind of analysis, and those are really restricted environments, and there should be some kind of good ways to process the data. So have been using R there But the problem is that in those environments, there is not much memory, or you need to pay a lot of money for getting those. So the DuckDB sounds very nice option to use larger than memory data in those environments. So I have been trying to get these things to work. So there has been a bit some implementation to additions to the R client, because I want to use this tidyverse or the deeply R syntax when I'm doing the analysis. So this is not a live demo here. I can switch to live demo if you want, but this is just a printout of it. Well, the first thing was that the DuckDB was there is so many new options coming in even between the releases. So I wanted to have some kind of easy way to install it and have the binary versions available and so on. So I tried to how to put this, or how to get this DuckDB to R universe, if you have ever heard about it. So it's a way to have these R repositories in the same way that CRAN, but it's not as strict in those rules. So I show here. So here is the DuckDB available here, so it's easy to install from here. This is totally unofficial, so if you think Hannes or Mark that I should remove this, then just please say. But I think this has been quite useful. So this automatically always compiles the new version, and this also includes those extensions that can be compiled with the R without any tricks. So it's a bit larger than the kind of official version. Okay, but let's get back to this example. So I have been working with this health data. So this is about the diagnosis. Well, first thing to do here is to setting up the connections. So that's the easy way. You all know that. So I will skip those one. Well, here is some kind of things that there is a lot of features in DuckDB, but the documentation is not up to date all the time. So it really takes some time to find the ways to do things. I think that there is so many tests in the DuckDB, so it's actually quite easy to see what is possible to do, but you need to do that and not trust to the documentation yet. I think that will be getting better and better all the time, but still. So first, there is good to put these pragmas. So well, at that, with this demo, there is a lot of memory available. So this is not actually out of memory case at all, but it will be important to put this limit if you have limited memory available. Well, then another thing that was kind of new to me in a way of how to think about using DuckDB or the databases. So actually the DuckDB database, even if it is a file, so as I used here it as a file, I think that it's not the way that you should use as a standard database. So that if you have some data, you should put it somewhere else, and the option is to use the Parquet files. So you have all the data that you want to make queries. You have those in the Parquet files, and then this DuckDB database it is just your own personal kind of place where you can do anything you want. So this is really if you need to share these files between several users at the same time. I think it was a bit problematic to use just the DuckDB database for that, but these Parquet files and the replacement scan, that's really cool thing. I think this works very nicely. So now with the DuckDB 033, it's possible to use here to register here when you are using this DB clear syntax here. You need to register the table so that the deeply R can see it. So now it is possible to just put this function here, so it works quite nicely. I can say that okay, use all the Parquet files starting with that thing. So that is in the 033 available. So let's look what kind of data I have here. So it's just a lot, well, just the data. So it's a individual ID and then the hospital and other things, and then there will be those diagnoses. So it's here. This is very small one. It's just 75 million rows here. I have hundreds of millions of those rows in typical data sets. But the problem is that when I get these data, those are coming from the register maintainers. So those can be in very tricky formats, or let's say not optimal formats to use in the analysis. So it's very typical that this data comes in a wide format, and I cannot do anything about it. They just give it in that format, and it's typically it's CSV file. Well, those need to be first converted to Parquet files. I will skip that. That's another thing. But one thing what I usually want to do is to transform from the wide format to long format. And this is, I think, that deeply R works quite nicely, or actually it's a function from tidyr, but db allows to use this pivot longer function. So I'm transforming from wide format to long format, and there is really a lot of those variables. I can use this kind of short code here. Then one thing to mention is that actually it's very nice that the DuckDB has these options there for the lists and so on, because it is possible here that in the one column or one variable there is several diagnoses that I need to kind of separate first. Those can be kind of, there's diagnosis asterisk diagnosis, and I just want to have one long list of diagnoses. So I can do that very easily with DuckDB using this unnest and string split regex. I think that is very nice, even easier than with R, I think so. Well, here is the code to do this pivoting. So you can see here that if I take the explain, so it's just using this explain from the DuckDB and shows the query here. So you can see that the query is well, quite long, complicated. So let's say that this is something that I don't want to write by myself if I can use deeply R there to use that. So this really is kind of long one. Okay, yes. So, and here is the physical plan. Let's go. Maybe I can put this. Well, let's go. It's not wide enough, but you can see here that then what is actually done. So this is, I think this is quite nice and really explains what really is happening here. Well, then I can easily get or run that and can see inside what is there. So it comes easily out. And then if I want to process that further, so count, for example, how many of certain diagnosis codes there are, I can use this kind of syntax and get this kind of results. So I'm really happy with DuckDB so far. So I think this looks kind of very promising, and the queries are very fast to run, and everything seems to work very nicely at the moment. So this was just kind of one example, and well, maybe not. It hasn't been possible until I would have, or I have sent some of pull requests to get some things to work a bit better in the R client, including the deeply R backend.
Yeah.
So thank you.
Thank you.
Yeah, thank you. Thanks for your patience. And you know that yeah, and it's great to hear that it's working out for you. This query looks quite daunting indeed. Okay. If there's questions for Reijo, is that the correct way to pronounce it, by the way?
Yes, it's Reijo.
Reijo.
Yes.
Okay. Then let's go to the next. If you have questions for you, maybe we can have people can ask you in the chat directly in the interest of time. And we will go to Talia next. Talia, can you share your screen maybe?
Yep. Cool. Hi, I'm Talia Schrilling. I'm a software engineer at Mode Analytics, and I'm going to talk to you briefly today about how we've been using DuckDB within our application. So just to give you a little bit of an overview, we're going to just briefly touch on these three topics. So this is very oversimplified, but it gives you a bit of a sense of where DuckDB or a different in-memory database plugs into our system architecture. Basically, it sits between S3 and our visualization engine to allow us to generate visualizations without having to interface more than once with the customer database. So for example, this is a screenshot of our query editor where I've run a query against a Postgres database. And the results of my query, in addition to being displayed in this view, are now saved as CSVs in S3. The service that queries the source database also submits a request to our Flamingo service, which kicks off a load of data into the in-memory database. That way, by the time the customer wants to create a visualization, their data is already loaded and ready for us to reference. As you can see, this allows the system to generate visualizations with relative speed, as well as allows the customer to experiment with different configurations without having to worry about spamming their database. So since 2019, when our visualization service first rolled out, we've relied on a different in-memory database to provide data to our visualizations, but we've had a variety of issues with it, which led us to seek an alternative, and that's where DuckDB comes in. There have been a couple of reasons why DuckDB has been a great fit for us. Use case alignment. The in-memory database that we're currently using, it definitely feels like we're trying to shoehorn compatibility. There's kind of a mismatch there, but the way that we want to use DuckDB aligns with the problems that DuckDB is trying to solve. Addressing concerns about resource utilization, the current solution has issues with DDL statements being slow, which DuckDB doesn't have. Support for future goals. DuckDB has on-ramps to things like Parquet and Arrow, which we are interested in potentially in the future using instead of CSV for data loading. And most importantly, the receptiveness of the team. The team has been super responsive to all of our asks and our requests, and that has made a real difference in our level of confidence moving forward with the solution. So as you can see, we're rolling out DuckDB in multiple steps via feature flags so that the customer experience is not impacted and we can feel a level of confidence about changes as we deploy them. So right now we are at that second step, which is that we are loading data both into DuckDB as well as our current in-memory database implementation. Customers are still being served visualizations from the old in-memory database, but on the side, we're comparing the results from DuckDB to the results from the other database, just to make sure that there's like data integrity and things are returning the way we expect. Pretty soon, we're hoping to start serving results from DuckDB to a certain percentage of customers. As that moves up, we will eventually get to 100%. And then the most exciting part will be when we can rip out the old solution and start working on features that were previously not possible. So yeah, that's all I have. Thank you.
Thank you so much. You know, it's super interesting because we've been getting a bunch of questions from you and we had no idea about this. So this is like actually relevant background information for us as well. Thanks so much for the kind words. I'm really excited to see that it's working out for you. Are there any immediate questions for Talia? If so, please raise your hand. No. You're also in the Discord. Yes, very good. It's a good place. We like our Discord. Yeah, we also, for people that don't know, we also have a Discord server. That's indeed a thing where you can talk to us. Yeah, Alex will post the link. Very good. Talia, maybe if people have questions, they can also ask you directly in the Zoom chat for the remaining time. Thank you so much for presenting, and yeah, looking forward to see what you do with the duck.
Thank you.
Thank you. Dan is next. You're also from Finland, right?
Yes, from Finland. Yes.
Somehow there's a cluster of DuckDB users from Finland.
Yeah, we like technology, and DuckDB is a good one. Definitely.
Take it away.
Thanks, Hannes. Alec is also here, so he's my colleague. So I'm not sure if he can be unmuted as well. Alec is here.
Oh, we have to make
I can make him a co-host as well.
No, we have to unmute him. But
yeah, but if I just unmute him, then if he mutes himself again, I will need to unmute him. It's
yeah, he's raised his hand. You should be able to find him.
That's why I couldn't see him, because it was yes, there he should be. You're a co-host as well now.
Thank you. Hey, Alec. Long time no see. Thanks, guys. Thank you for being here. It's really honored. So we've been following DuckDB for past 3 years roughly. So I've been bugging Hannes. I mean, I remember I was bugging Hannes with Parquet reader bugs back in a year or two. But it's really good one now. Yes, we have background in like cloud computing, big data, but not in data science in a sense. But I've been working on Amazon Cloud related projects past 10 years. So yeah, and serverless, Lambda, and democratizing data on S3 data lakes. That's the kind of passion. With open data formats, of course, and being able to query the data like terabytes and petabytes that you have on your lakes. So we decided to kind of figure out how can we run DuckDB in Lambda, because it's been improving a lot. We have 10 gigabytes of memory and 6 cores in a single Lambda function. That's like a small laptop back a few years, and now you can run them like 3,000 in a second. That's like a whole lot of data. But yeah, Alec, can you
Yeah.
introduce yourself?
So I'm Alec. I tend to work on product management side of things, not engineering or data science. And Dan and I worked together for a few years for a big company who we had thousands of terabytes of data in a data lake, and enterprise customers who would randomly log in and start querying random bits of data really hard. So we'd end up with the whole system crashing at 10 a.m. on a Monday morning because everything was inelastic and it was horrible. So yeah, that's why I'm really excited to be boiling data, because we're trying to solve that problem and make it so that we don't have the noisy neighbor situation or having to keep loads and loads of data hot all the time.
So straight to the point. So let's see the demo. So we have been cooking up something behind the scenes, and well, it's open for registering to preview. You can do that. But let's see the application itself. So I need to sign in, and when I'm signing in, the service will take my credentials to my S3 bucket. Need to move this window somewhere. Yeah. It's using my credentials on my data lake, and I can browse my files. Okay, I see that I can upload files as well. So I have uploaded one file there, and well, let's query it. So it's going to do a query directly on S3. It's a very small file. The Parquet metadata is now in cache, so the next query is faster. We have a query log here, which is part of the WebSocket API that we are building, because with Lambdas, you only get to have one response back. But if you hook it with the WebSockets, you can send your information about your queries, the data itself, events about the Lambda being warm or cold, warming up, and things like that. So we have a connection time here, which means that how long time it took to read the data from S3 into memory, and then the query time itself, like measuring the DuckDB performance. The next query took zero milliseconds because it's in memory, and the count is obviously cheap. So yes, we are taming the Lambda containers in a sense that we see when the containers are hot and warm. And when you have Lambda function warm, all the memory you can use, it's there available for you, but you don't pay anything unless you start firing up queries or calling the Lambda itself. So we keep a book. We have a bookkeeping about these warm Lambdas, and let's have a proper demo as well. We have New York taxi records, and there are some comparisons against Parquet format, DuckDB format, it's DD compression and things like that. But I think this hopefully is more interesting. So we took the common crawl data format. We parsed the JSONs, the HTTP the data basically, and we took all the domains and cross-domain links, and we put it into separate data sets. It's roughly 1.6 billion rows, and it uniquely identifies all cross-domain links between domains in internet and their accounts. So what we do here, we basically fire up 49 different Lambda functions which start to warm them up. And well, let's take a simple query. And we start to see the API is giving up events of Lambdas. So we have now 49 Lambdas warming up, reading data from the S3 data lake. It's roughly, how much was it? 65 gigabytes in uncompressed format. So there's one still left. So now it's all warm. And when it's warm, the results should be coming really fast. So if we check the query log now, this one was running connection time average, well, 14 seconds reading the data, and then query time 7 milliseconds. It's simple. Take one row. We run it again. You get the same results, but now everything is in memory. So connection time is, oops, it's from this one. Connection time is almost nothing, but the query time is roughly the same. Okay, and then when you have the data in memory, this 65 gigabytes, you can query it fast. We can, for example, find out whether, what are the domains that link to DuckDB core, where target domain like DB, or is that correct? So referring to target domain, yes, let's run that one. So we get some results, and while we're doing that, we also see the costs of the actual queries, because Lambda is cost, you pay per use, it's pay per milliseconds. So you can follow up your costs as well. Of course, the data sets are separate, and we don't have a DuckDB WASM in the browser yet to kind of combine the results and aggregate them and things like that. But that would be a nice, obvious improvement to this this interface.
Yeah, very cool. I think in the interest of time, maybe we can wrap up. Is that okay with you?
Yes.
Okay.
Where did I stop sharing here?
Great. Thank you. Okay. Thank you, Dan. It's super exciting. I think you have really impressed me with this daft idea with these lambdas when I first heard about it, and I'm glad to see that it is now working. It's really cool. It's really cool to see.
This will be free for DuckDB. Base version will be free forever as a tribute to DuckDB. And if we ever get any real business going, we will be part of the foundation as well. But now it's like interest, and happy to hack these things together.
Yeah. Thank you. All right. I think we are there. We think we have reached the end of the program. Let me do some announcements still. So if you want to continue talking to us, I think the chat has been quite active during today's meetup, and I quite enjoyed this. If you want to talk more to us and have questions or whatever, do join our Discord. The link is in the chat there. Basically you can just join and type away. I would also like to just very briefly show you the show you this new button on our website here, where if you want to receive free DuckDB stickers, you can click a button here and then you will receive them in your mail. So if you want some DuckDB stickers, which are among others also hex shaped, you can put them on your devices if you like us. Mark, did you have anything else that you wanted to add?
Oh, maybe we could thank all of the Lightning Talk speakers and John, of course, again. I think it's been a great meeting.
Yes, thanks to all the speakers again. Thanks for all the Lightning Talk speakers. Thanks for all the praise, also the constructive criticism. I guess anything else? No? Okay. Well, again, thanks all, and then we shall go to bed. So thanks everybody, and talk to you soon. We will we have a follow-up eventually. We don't exactly know yet when, but we will announce it. Yeah. Thank you so much.
See you, everyone.
Bye-bye.